Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 232, implement queue using stacks. We're told that we need to implement a first in, first out queue using only 2 stacks. The implemented queue should support all the functions of a normal queue, and we need to implement the myQueue class. So we've got 4 methods: push, pop, peek, and empty, and we can only use standard operations of a stack. And we're given some examples here. So basically, in essence, we need to implement a first in, first out queue. So a first in, first out data structure where the first element that we add to our data structure is the first one out. However, we need to use a stack, which is a last in, first out. So the element that when it comes to a stack, the element that we push to a stack at the top of the stack is the first one that's out. Whereas with a queue, the first element in is going to be the first element out. So the way we can solve this problem is by using 2 lists. And it's going to be a bit confusing as to why we need to use 2 lists. So I think I'll hop straight into the code and it will make more sense once we start getting coding. So I'm going to start off with the init function. So this will initialize our queue stack, our queue data structure. So we'll set our in stack, which is our first stack, to an empty list, and our out stack equal to an empty list. Okay, so the first method that we need to look at is push. Well, push is literally just pushing an element to the back of the queue. So there's nothing fancy that we need to do here. We can just say in stack. So in stack is going to be all the elements which go in. Out stack is going to be for the operations where we're taking an element out. So in stack.append x. So this is like super basic and self-explanatory. Pop. Now pop is interesting because we need to remove the element from the front of the queue and return it. Well, let's have a look at this problem. So let's say we've got a queue like this, 1, 2, 3. We want to get element 1. We want to pop, but if we use pop on a stack, we're going to get 3. So we're going to have to pop 3, pop 2, and then pop 1, and then get 1. What if we were to reverse this list and then pop? Then we would get 1, wouldn't we? So for example, if we go to 3, we pop 3 from our in stack, and we add it to our out stack. We go to 2 now, and we pop it from our in stack and append it to our out stack, and again for 1. Well, now we just have to pop from our out stack, and we'll get our intended result. And we can do the same kind of logic for peek. So this makes our life a lot easier because it allows us to simply just pop and peek from a stack which is now in the correct order. So the way we can do this is by creating a help function. So we'll call it transfer. So let's create our help function called transfer, and we're just going to return none. And we're going to say if not self.outStack. So if our out stack is empty, because we want to make sure there's no elements in our out stack. If there are, it's just going to cause ordering issues. So we want to say if our out stack is empty, then while self.inStack. So while there's elements in our in stack, we're going to append to our out stack. To our out stack, we're going to append self.inStack.pop. So this will pop elements from our in stack and put them into our out stack, where we can then do the rest of the logic. So let's say self.transfer. So this will take all our elements now in our in stack, reverse them, and put them into our out stack. Now all we need to do is say return self.outstack.pop. Simple as that. Now for peek, well, we can do the same thing. We can transfer all the elements from our in stack into our out stack, and we can say return self.outstack -1, which will give us the last element of our out stack. So we can't just, because we have to use stacks, this would be a lot simpler if we didn't have to use stacks. We could just say self.inStack at index 0, and that would give us the first element, but we can't do that. We have to transfer all our elements from stack 1 into stack 2, and then return the last element of our out stack. And I think it's important to also mention that although we will have elements in our out stack, we'll also have elements in our in stack. So our stack will basically be comprised of both our in and out stack. So half or parts of our stack will be stored in stack, and the others will be stored in out stack. So for our empty method, we just need to make sure that both the elements from our in stack and out stack, both of our in and out stacks are empty. So we're going to say return self.inStack is empty, and if self.outStack is empty. And that should be the code that we need for today. So let's run our code. Fantastic, we pass a sample test case. Let's submit our code. We pass all 22 test cases. So in terms of time complexity, we're looking at an O of 1 constant time complexity, but that would be amortized since we are using the transfer function, which would be O of n time. But in general, we're looking at an O of 1 amortized time complexity, and space complexity, since we are storing our elements in 2 stacks, it's going to be O of n space complexity. So I hope this video made sense, guys, and I'll catch you in the next one.